Hey kiddos. All right. All of my favorite students today. I wanted to show you. We have a note card today. It's on triangular prisms, which are just like what we talked about yesterday. Only now we're talking about the nets of a triangular prism. So yesterday we talked mostly about rectangular prisms. This is kind of like the same thing, but with triangles as your bases. And every prism has bases that are matching, that are the same. So for instance, in this case, the bases would be the top base and the bottom base right here, right? They are the triangles, and that's why we call it a triangular prism. The prism refers to the fact that it's connected by rectangles, but the triangles are what gives it its real shape, like this idea of a triangular box. Or if you've ever gone to the store and bought a Toblerone candy bar, you should look for them. They're, I think, a Switzerland company, but you can buy these candy bars in the store. They're a little expensive, but they're in these beautiful kind of equilateral triangle bases with a rectangular middle. So it's like this perfect little thing that slots into the packaging. It's really cool, and they taste really, really good. So you know how I was saying the cats always interrupt me? They're hovering. So we might get a cat cameo today. We'll see. We'll see. I'm not going to encourage them, but they're just kind of around. So maybe. I guarantee there will be no kids popping in today because they are all asleep, which is good because it's very late at night. But I wanted to show you something. So if we're making this idea of the Toblerone bars, I should have looked up a picture of this. I don't have it. I should have. But in any case, the Toblerone bars are a really great example of when you would use a box like this. But so notice that a triangular prism has three rectangular sides and two triangular sides. So altogether, we have five surfaces or five different sides. And when you put it together, when you fold all the parts, it turns into this shape, right? Where a triangular top, a triangular bottom, and then the yellow and the orange side become our two of the rectangles. And the last rectangle, where is it? It's on the back side. You can't see it, but it's back there, right? So a net for a triangular prism has three rectangle sides and two triangle sides. And that's true of every triangular prism. Now, what is interesting about triangular prisms is sometimes they come in different shapes. I'm going to show you another one right now really quickly. Check this one out. This one, also a triangular prism, but it looks quite different. But notice that the two triangles, the one on each side, are the same, right? It's just a reflection or a symmetry of the one before. So this is the exact same shape as that one. It's just that they're like in a different orientation. One's flipped. And the idea here is that when you put this box together, this would also make a triangular prism. It would just be that in this case, the sides would not be all the same. So in the one I have in my example here, all the sides are the same. In the one that I just showed you on the grid, they are not. And we're going to talk about that. Now, how do we do this? Well, this is pretty interesting and also a little bit advanced for some of you. We've talked a little bit in my sixth grade class about a lot actually, about how a triangle, the area of a triangle or the size of it, the shape of it, not the shape, the area of it, how much space it holds or how many squares it holds, is half as big as what a square would be. So if you take a Post-it note and cut it in half, right, you make a triangle. If you cut it in half diagonally, a Post-it note, cut it in half or fold it in half, you've basically taken half of the area, right? Because you've cut it in half. It's made a triangle. So whenever you find the area of a triangle, just like you do with a rectangle, you need the base and the height. And once you have the base and the height, you just cut them in half, like not that hard. That's the difference. So I'm going to open up this little note here so you can see what's underneath here. This is how we find the area. Oh, maybe I should let me see if I can, let's see, we'll just open both of these up. This is going to be better here. I'm going to show you how to find the area of both of these. So there we go. Let's just focus on this right now. So a little messy, but that's all right. All right. Now, in order for me to solve this problem, and I do want you to draw this and write this down. This triangle, we need to know the area, right? And that's this triangle here on the end. It's an equilateral triangle, or it's actually really close to an equilateral. It's probably more of an isosceles. But in any case, we know the base being 4, right? We know it from right there. We know the height is 3, and the height goes straight up. So to find the area of a triangle, we go base times height divided by 2. Just like I said, it's like a Post-it note being folded in half diagonally. It's half as big, right? We folded it in half. Wow, that's shocking. Fold it in half, half as big, right? Okay, so base times height divided by 2 gives us a area of a triangle. We always have to remember that. It's the most easy thing to forget is to, when you do it, to just go 4 times 3 and say, oh, 4 times 3, 12, and forget to cut it in half. But so what we have to do is go base times height, 4 times the height, which is perpendicular, just like a parallelogram, just like a rectangle. We say base times height is 4 times 3 gives me 12. And then I divide by 2. When I divide by 2, I get 6. And my area for this little tiny guy, if my dimensions are 4 centimeters by 3 centimeters high, is 6 centimeters squared, or 6 square centimeters. Now, for my sides, the rectangles, that's easy, base times height, or length times width, whatever you prefer, as long as you're multiplying the sides that touch each other at the corner. Right? The idea is that you can't multiply 4 times 4. That doesn't make any sense. You want to multiply 4 times 10 because that's the shape that comes down the side, right? They're adjacent to each other. You're always multiplying that. If there were squares like there are here, we can just count them, but we don't have that. So on this one, we have to actually look at the dimensions, which are 10 and 4, 4 and 10. So this one is 40 centimeters squared. So as you can see, the area of the rectangle is way, way bigger than the area of the triangle. Now, in order to find the surface area, we need to think about this and say, well, you know what? I now know that all of these areas for this rectangle is 40, right? So what I need to do is add them up. So how many are there? I'm going to have 40. Oh, let's get up here. We're going to have 40 up here, right? This is 40. We're going to have 40 here. I'm doing a terrible job with my fours today. I apologize. And 40 there. We have to add those up. Those are all of our areas. We also know that on the sides, we have 6, only 6. Can you believe how small that is? And over here, once again, only 6. So our surface area of this net is to add up those 5 sides. 6 plus 6 plus 40 plus 40 plus 40. And you know me, I'm definitely going to do the 40s first. 4 times 3 is 12. 40 times 3 would be 120. And then I'm just going to add the 12 on. I'm going to add 6 plus 6. So 120 plus 12 gives me 132. And that is where our surface area comes from. So I'm going to move this down here so you guys can see it. Our surface area is to add all 5. 6 plus 6 plus 40, 40, and 40. 132 centimeters squared. That's how much paper, how much cardboard it takes to make this shape, right? Interesting. Not too complicated, but still interesting. Now, what I want us to do next, and you can pause it here if you need to take these notes and get them all down. This is a note card. You'll put it in the note card file. You'll put it in your notebook, and then you'll upload it along with the yesterday's note card. You know, yesterday was rectangular prism, today triangular prisms. And then what we're going to do is talk about this one. How do we find the area for this note card? Now, this one's different, like I said, because every side is different. And I want you to think about when I fold this thing up, like when I start to kind of work with this, when I fold this piece and this piece together, notice that it's long. Notice that, like, on the triangle, this is my longest side, right? It's longer than this and it's longer than that. I know that that side and that side should be the same length. Now, whether they are in this drawing or not, I think they are. They should be, though. So that tells me how long they should be. So if this side right here is 1, 2, 3, 4, 5 long, right? And I'm going to kind of bring this down a little bit. If this side right here is 5 units, right? That's what we're going to say. This is 5. Let's call them centimeters. I like centimeters. We're just going to call them centimeters. That means that this side has to be 5 centimeters because they have to match up. Right? Does that make sense? And now we can look at our base and our height. Look at our triangle. On this side, I see that this has to be 4 centimeters, right? And this one, because I'm counting, right? 1, 2, 3, 4. Counting is hard. I know, guys. Counting is hard. All right, now this way. What's the dimension from here across? Well, that has to be 3 centimeters, right? Clearly, 1, 2, 3. Now, even though these little corners are cut, right? Some people don't know how to count that. Well, because you're counting a length along a line, you still count it directly. You count like straight ahead, like 1, 2, 3, 4. That seems obvious, but some people kind of have trouble with that. Now, take a look at these base and height. That 5, I don't need, I don't care about. What I care about is my area. And my area could be I count all the squares, or I could just say the base times the height. Remember, base and height are what are on the 90-degree angle. Base and height would give me 4, the area right here. And I'm going to put this over here. Area, let's see if I can do it without me covering up my thing. Area equals base times height divided by 2. And that would be, base would be 4, height would be 3. Remember that dot means times, divided by 2. The 2 is something we just have. And then that would be the same as we had before. 12 divided by 2 equals 6 centimeters squared. It just happened to be the same. I didn't mean for it to be the same. It wasn't planned like that. It just happened. Okay, so this area is 6 centimeters squared, right? And I put the squared there, so now I'm talking about squares. Over here, let's count them. 1, 2, 3. Those are my full squares, right? What about my partial squares? Doesn't this one go together pretty nicely with this one up here? That's my fourth one, right? I can call that number 4 along with that. Doesn't this little partial square right there fit pretty nicely with this partial square, right? And we could call that one our 5th square. And our 6th square, we could say, is kind of like this little guy in here with the little chamfered corner. That little corner is up here. That's our number 6. So how many squares do we have? Oh, wait, we already figured this out. 6, right? 6 squares. Ta-da! So our triangles are the same. So our two sides, when we say triangles, we're going to say surface area. So surface area, right, equals, we're going to say 6, or all of our sides, 6 plus 6, right? That's good. And now, those are our triangles. This is our triangle, and this is our triangle. Now we got to add in our rectangles. So let's look at our rectangles. So I'm going to go changing colors now. Let's make this one blue. This one down here, 4 times 6. I hope you guys can all see that. 6 here and 4 there. I hope you don't take issue with my counting. So I know the area of this shape is going to be area equals 24 centimeters squared. Okay, we'll change the color again. Let's make it another blue. The area in here, I'm going to go across the bottom and up the top. We already did the 3. We already know about that 3. That's the same, right? 3 times 6, because that's 6. That means this must be 6 by transference. So 3 times 6 means the area here must be 18 centimeters squared. 6 times 3. And now let's go with one more shade of blue or purple. Let's do purple. I always pick purple. This one, 5 base and height, or base and height. You could say 6 down here, 5 there. So you guys all know by now, if you know your math facts, the area here is 30 centimeters squared. Now, notice how much smaller, these numbers are way bigger than the triangles, right? So what we're going to do is say 6 plus 6 plus 30, that's a rectangle, right? Plus blue, we're going to say plus 18, that's our middle rectangle. And then lastly, plus 24, right? Plus 24, and that's our bottom triangle, or I'm sorry, rectangle. We add all these together. I look for numbers that go together nicely because I love to do mental math. 24 and 6 give me 30. I like that a lot. 30 plus 30 gives me 60. I like that a lot. 60 plus 18 gives me 78. Because, 60 plus 20 would give me 80, so minus 2 is 78. And 78, I've already done all these, 78 plus 6 would give me, let's see, 78, 79, 80, 81, 82, 83, 84, 84. So surface area, you guys thought I have to count on my hands? Sometimes, right? Sometimes I count on my hands. I think it's okay. Still pretty fast with mental math, even though I like counting on my fingers. All right. That's why we have fingers, man, just so we can count. Surface area of this thing equals 84 centimeters squared. What that means is if I counted up, let me see where I'm on time here. Am I going to, oh my gosh, I'm almost done. If I counted up every one of these squares, it would be 84 centimeters squared. I'm going to cut this short I'll see you guys later.